Okay, so the difficult part has finished. You now have went through the derivation of the optimal menu of contracts. Now let's read the result and do some implications. When we were working with the two-type model, we have mainly three things. We have monotonicity, efficiency at top, and no rent at bottom. Now let's see whether they are still true with our continuous type model. So of course monotonicity is still there, right, at our very first step 1, or at the end when we do the final check. So monotonicity is there. For higher type, the quantity designed for him would be larger. And then how about no rent at bottom? This is exactly an outcome of our binding IR constraint for theta 0. Okay, if you want to have a fresh memory of that, go back to our step 5, I believe. Yeah, that's where we show that at any optimal solution, that constraint should be binding. If you want to see that from the optimal contract, there's no problem. So T of theta 0 should be calculated according to the T formula by plugging theta 0 into theta. And then the last term here is 0. There is nothing to collect from this integral. So you have this, and because W of theta, by definition, is the utility you obtain by consumption minus your transfer, if you observe that they are the same, then you understand that this is 0. So all the higher types, they will earn positive utilities, or which we mean information rent, because they have their private information, because they have the threat to lie. So they can earn information rent, but the lowest type is just so unlucky. There's no reason for him to lie. So there's no reason to leave him any information rent. Okay, no rent at bottom. But again, now we actually learned some more things. No rent at bottom becomes no rent only at bottom. When you have two types, you don't really know when it is generalized to more than two types. Will we always have no rent only at bottom, or we will have no rent for more than one type, right? We only know that the low type has no rent, the high type has rent. We don't know what will happen if we have more than two types. Now we can answer this question. When you have more than two types, when you have, for example, a continuous type, then only the last type, only the lowest type has no rent. So we have no rent only at bottom. And now, how about efficiency at top? What we want to show is that for the top type or the highest type, the quantity is efficient. So we need to first find the first best quantity, which is denoted as Q of FB, and the second best quantity, Q star. And here is the formula for Q star. And if you go back to look at the original problem again, even though we didn't derive that for you, you should be able to derive that Q first best is satisfying this particular equality. Or you may make some comparisons between this and the two-type efficient problem. So let's assume you can do that by yourself. And now let's compare these two equations. Okay? So first we know 1 minus capital F over small f would be positive. Okay, for sure. The denominator is positive, the numerator is positive, as long as your theta is not the highest type. So as long as your theta is not the highest type, theta is greater than this particular term. And that means, okay, if this is greater than that, then the blue part must be smaller than the blue part here. And that means you have this inequality. Now again, because V prime is decreasing, so that means your Q of first best must be greater than Q star. Okay, which is exactly what we need for this particular thing. Okay, so what does that mean? That means as long as your type is not the highest type, then your quantity, your second best quantity, has a downward distortion from the first best quantity. Okay? Only for theta 1, we have that this particular ratio is 0, and then you have no distortion. You have no distortion. So some conclusion, except for theta 1, we always have a downward distortion on quantity. Efficiency at top now can be generalized. Now we know it's efficiency only at top. Why is that? The reason to do downward distortion is that we want to prevent a high type from mimicking a low type. Because if your type is high, then you prefer high quantity. So if I cut down the quantities for low types, then you would have no incentive to lie. I need to do that to cut down your information rents, but when I do that, I also sacrifice some efficiency. So I need to find a trade-off. I need to find an optimal balance between efficiency and the rent extraction. All of these are exactly the same as what we did with just two types. Okay, so summary. We have introduced a screening model with an infinitely many types of agents on a continuum. Okay, a continuous type screening model. All those implications from the two-type model are still valid, and moreover, they are also extended. We had monotonicity. Now monotonicity is still true throughout the continuum. It's not one is greater than the other one. Now it's throughout the interval, it is increasing. In the past, we have efficiency at top. Now we have efficiency only at top. We know that the top type is still efficient, and for all the others, it's inefficient. In the past, we have no rent at bottom. Now we have no rent only at bottom. Okay, some new findings are added. Throughout this lecture, we also take this chance to learn or review some useful concepts or techniques, like hazard rate, integration by parts, and envelope theorem. Okay, they are also some useful things that if you continue the research direction in this way, they will be used in the future. A continuous type model can actually be useful when you do research because, as you can see, it is more general than the two-type model. Okay, more general than the two-type model, and it's much less tedious than the n-type model. When you have n types, actually your calculation or derivation would be very messy because when things are discrete, you just need to deal with them one by one. But when things are continuous, calculus can really help you a lot. Your derivation would be actually clearer. So, given that this is a course teaching you research methodology, and that's why even though the continuous type model is so difficult, we still need to take this lecture to really formally introduce that to you. Okay, I hope you enjoyed. Thank you.